Good morning, class. Here's module 4 of pre-calculus test for test 4 covering section 5.4, chapters 8 and 9. Here's chapter 8, application of trigonometry, polar coordinates, and vectors, part 2. Let's continue with complex numbers. Complex numbers are in the form of a plus bi or x plus yi. In polar form, r times cosine theta plus I sine theta, or simply r cis theta. R squared is x squared plus y squared. Modulus, or the magnitude of z, or r, is square root of x squared plus y squared. Tan theta is y over x. To multiply two of them, you multiply r1 and r2, and then you add up theta 1 and theta 2. To divide them, you divide r1 and r2, then cis theta 1 minus theta 2, and according to de Moivre's theorem, if you want to raise it to the power of n, you raise r to the power of n, you multiply theta by n. Again, r is the magnitude, called also the modulus, and theta is the argument. So z equals 8. We want to find complex cube roots. So how do we find them? In general, when a number is in the form of r cis theta sub 0, let's say, for n being larger than or equal to 2, there are n distinct complex nth roots of w. In this case, complex cube roots, we are looking for 3. So the way you do that, you say z sub k, you take the nth root of n, cis, and then theta sub 0, whatever this is, divided by n, and then you add 2k pi using radians, or 360 times k using degrees, divided by n. K is all the numbers from 0, all the whole numbers from 0 all the way to 0, 1, 2, all the way to n minus 1. So what is this one? Notice 8 is a positive real number. And remember, the real axis and the imaginary axis. Real axis is the x-axis, imaginary axis is the y-axis. So when z is just a real number, that means if you're looking at a plus bi or x plus yi, y is 0, we only have x. That's the meaning of it. In which case, the angle theta is 0. So w equals 8. 8 cis 0 is the shorthand notation, or 8 cosine of 0 degrees plus I sine of 0 degrees, or 8 cis 0 degrees, or 8 cis 0. In this case, this is in radians. 0 is 0 no matter what. So the point is you can go with both methods. So having said that, we're going to continue with these thoughts, and we're going to say z sub k is the nth root of r cis theta sub 0 over n plus 2k power over n, and we are going to replace the r with 8. Okay, n, we want the cube root, the third root. So theta sub 0, we replace it with 0. And if we're going to go with the radians, as I said, 2k pi. Needless to say, this is 0, 0 over 3 or 0. So basically, we have 2 cis 2k pi over 3, and k is 0, 1, 2, 3, all the way to n minus 1. What is n? N is 3 because we're on the cube root. So 0, 1, 2, we stop at 2. By the way, if you go to 3, it repeats itself, okay? Along the circular path, in essence, more than 2 pi radians. That's what happens. And so having said that, let's plug in 0. If I plug in 0, I get 2 cis 0. Let's plug in 1. I get 2 times 1 times pi. That means 2 pi over 3. 2 cis 2 pi over 3. Let's plug in 2. We get 4 pi over 3. 2 cis 4 pi over 3. That's what we get. So let's evaluate each one, starting with 0. As you know, Cosine is 1, sine is 0. It's simply 2. 2 pi over 3. 2 pi over 3. First, I want to remind you that the reference arc, let me write it here. Reference arc is simply pi over 3 for that. Okay. So they're just like pi over 3, cosine of pi over 3, but both of them, of course, in the second quadrant. Cosine is positive, sine is negative. So this cosine of pi over 2 is 1/2, but this is negative 1/2. Sine of pi over 3 is positive square root of 3/2, and in the second quadrant, sine is positive. So we're going to multiply by 2. The result will be z sub 1 is negative 1 plus I square root of 3. We're going to do the same thing with 4 pi over 3. Now, 4 pi over 3 puts us in the third quadrant, same reference arc. Cosine is still negative. Sine is also negative because in the third quadrant, sine and cosine are both negative. So therefore, we end up with negative 1 minus I squared of 3. So what happens in general, if we are dealing with a real number? Note, if n is any real number, and n is positive, n cis 0. If n is negative, n is n cis pi, because cosine of pi is negative 1. So that's a general statement, pretty straightforward. All right, let's switch gears and let's look at vectors. Vector v has initial point P and terminal point Q. Write v in the form AI plus bj. Find its position vector. Also find its magnitude. P 3, 2, Q 5, 6. Okay, so what do we need to do? Let's go over a couple of things first. Number one, what is a position vector? If a V is a vector with components A, B, is an algebraic vector whose initial point is at the origin, then V is called a position vector. So it becomes a position vector if the initial point is at the origin. Algebraic vectors are in the form of V equals AI plus BJ, or in a component wise AB. A and B are called components of the vector V. This one is called angle brackets, sometimes known as chevrons, are used to represent vectors. Okay. So if the magnitude is 1 along the x-axis, we end up with the terminal point of 1, 0. This is the I vector. If it's along the y-axis, 0, 1, this is the terminal point. This is the j vector. Therefore, AI plus bj. Okay. So those are unit vectors I and j. Also, let's look at these two. These two vectors are identical because they are parallel and they have the same size. Notice a vector with initial and terminal points P having coordinates x sub 1, y sub 1, Q having coordinates x sub 2 and y sub 2. So the initial and the terminal is equal to the position vector V PQ with this arrow is x sub 2 minus x sub 1, comma, y sub 2 minus y sub 1. Notice this along the x-axis, along the I vector is x sub 2 minus x sub 1, along the j would be y sub 2 minus y sub 1. And therefore, these two are identical vectors. The difference is this is called a position vector. So having said that, what would be the position vector for this one? Well, we are going to use the same formula. So x sub 2 minus x sub 1. So 5 minus 3, y sub 2 minus y sub 1, 6 minus 2, which is 2, 4. So those are the components. Okay. just for the sake of argument, um, if one tick mark is 1, 2 comma 4, go 2 to the, let me just, 2 to the right, 1, 2, 3, 4 up. This would be the position vector for this one. Okay, position vector is pretty straightforward, everybody here. All right, so having said that, let's look at the format with AI and BJ, exactly the same thing. 5 minus 3i, 6 minus 2j, or just use that and write down 2i plus 4j. That's absolutely the same thing. All right. The next thing we want to come up with the magnitude. So what is the magnitude, everybody? Magnitude of the vector is square root of a squared plus b squared. The magnitude is always non-negative. Can it be zero? A zero vector, of course. If the magnitude is zero, the vector is a zero vector. And the magnitude of two vectors that are opposite minus v and v are identical in magnitude. And if you multiply it by a, you can take the a out in a way of an absolute value. So having said that, the magnitude is the square root of a squared plus b squared. Therefore, 2 squared plus 4 squared. This is 4. So let's just write it. This is 16. We get 20. 20 is 4 times 5, so makes it 2 square root of 5 precisely. Okay, that's the exact answer, everybody. Given v is negative 2i plus 3j and w is 5i minus 4j, we want to find the magnitude of v and then v plus w to v minus 3. W reminding you of the position vector, magnitude of the vector. And as far as the sum is concerned, I'm going to quickly go over that. If you want to add u and v, two vectors, okay? So the terminal point of one is connected to the initial point of the other. And if you look at just u and v, then from the initial point of the first one all the way to the terminal point of the last one is u plus v. Now, if you want to add w to that, then here's the terminal point of u plus v. Here's the initial value of w. You connect them and the red one. So this is how you do that, the triangular method, the parallelogram method. Having said that, let's start with the magnitude using the formula. For v, we have negative 2 quantity squared plus 3 squared. Under the radical, we get 4 and 9, and it's square root of 13. V plus W, just add up the components, everybody. Minus 2i, positive 5i, they add up to 3i. 3j minus 4j is minus j. By the way, because this is a positive sign, nothing changes. If it's a negative, you have to distribute it first before you move on. What about 2v minus 3w? Okay. Well, very simple. All you have to do, multiply v by 2, multiply w by 3, and subtract negative of this, negative 3w from 2v. So we're going to write 2 times v minus 3 times w. So let's distribute here. Minus 4i plus 6j. This is what I mean. You definitely must distribute. Minus 15i plus 12j. Clearly, we get negative 19i. And over here, these two, 18j. This is the final answer. Find the magnitude, direction, angle, and a unit vector in the same direction for the vector v equals 3i plus 3j. Obviously, we have this stuff, and we can easily find the magnitude just following the formula. Square root of a squared plus b squared is 3 squared plus 3 squared. Okay. So this is 9, and 9 is 18, and 18 is 9 times 2, and we get 3 square root of 2. That's why we get square root of 2. I hope everybody is okay with that. Then the next thing, direction angle, reminding you of what is going on. So if you have a vector makes an alpha angle, beta angle, theta angle, whatever, with the positive side of the x, then that is called the direction angle. Alpha, which is between 0 and 360, between the vector and the I, okay? The unit vector along the x-axis, I. Then the vector v it's the product of its magnitude and cosine of alpha I plus sine of alpha j. So having said that, we need to find the alpha, and to do so, as before, tan of alpha is b over a. So the vector uh, is ai plus bj. A and b happen to be identical. And this is the first quadrant, by the way, right? It's important to pay attention to quadrant when you want to clearly find out of what the angle is. So this is equal to 1, the tangent, because it could be in the third quadrant. That's also 1, okay? This is 45 degrees. Because we know it's in the first quadrant, it's 45 degrees or pi over 4. So you want to pay attention to that. So having said that, based on this formula, we are going to replace the magnitude with 3 square root of 2 and alpha with 45 degrees. And so therefore, we have 3 square root of 2 parentheses cosine of 45 degrees I plus sine of 45 degrees j. So that's how the vector is defined. Now, the next thing is the unit vector. Again, reminding you a couple of things. Number one, I'm going to remind you again, along the x-axis, the I vector is called the unit vector, and the terminal point is at 1, 0, 0. Remember, the position vector is always at 0, 0, the initial. The terminal at 1, 0. In this case, the terminal point is at 0, 1. That's the j vector. Both of them are unit vector because they have magnitude equals 1 in both cases. So having said that, unit vector in the direction of v would be the v divided by its magnitude. Because if you do that, then the magnitude changes to 1. Now, v with components a, b is a times 1, 0 plus b times 0, 1. 1, 0 is the I vector, the unit vector along the x-axis. 0, 1, the j vector, the unit vector along the y-axis, ai plus bj. So having said that, we are going to go with that formula. We are going to use the v and divide it by its magnitude, 3 square root of 2. So let's make up two fractions. Let's see. So this is 1. And I hope everybody knows that 1 over square root of 2 is square root of 2 over 2, right? So square root of 2 over 2i plus square root of 2 over 2j, we rationalized it in essence. Write the vector v in the form ai plus bj, given its magnitude and the angle alpha it makes with the positive x-axis. Also find the unit vector in the same direction for the vector and check its magnitude to be 1. The magnitude is 14, alpha is 120 degrees. So let's plug in and replace this with number 14, alpha with 120. Now, let's discuss the reference arc again. Obviously, for 120 degrees, the reference arc is 60 degrees. In other words, 180 minus 120. So that means they both have the same value as 60 degrees cosine as well as sine. However, 120, it's in the second quadrant. Cosine positive, sine negative. So cosine of 120 is the same as cosine of 60 1/2, but makes it negative 1/2, whereas this one is the same as cosine of 60 positive, square root of 3 over 2. So obviously, if you distribute, this becomes minus 7i, this becomes 7 square root of 3j. So that's pretty straightforward, everybody. Now, what about the fact that it's a unit vector? What about the fact that we want to get the unit vector? All you have to do, divide by 14. So we make up two fractions. Let's see. This one, I hope you see it's negative 1/2 I. This one is square root of 3 over 2j plus. Okay. So again, pretty straightforward. I hope everybody is fine with that. Now to check, all you have to do, raise this one to the power of 2, you get 1/4. Raise this one to the power of 2, you get 3/4. They add up to 1. And this is really good enough, but really, if you want to be more specific, square root of 1 must be 1, which obviously it is. So that's not a big deal. I hope everybody can follow that. And we are going to move on. Okay, now here's an application problem. A plane is flying at a speed of 200 miles per hour on a bearing of north 55 degrees east. I want to stop here right away, reminding you north, south, this is east, this is west. So if we are going north, east, so north, east, so towards north, we make a 55-degree angle, and that would be north 55 degrees east. So that's the first thing we want to make a point of. All right, so that's the direction that it's moving or flying. The wind is blowing from west to east in this direction at 35 miles per hour. Approximate the ground speed of the plane to the nearest miles per hour and the true course of the plane to the nearest tenth of a degree. So if that is the case, and this is 55 degrees, remember, in this format, the alpha represents the angle between the vector and the positive side of the x-axis, or the I vector. So this angle is 90 minus 55. So it's 35 degrees. So the plane is flying with the 200 miles per hour speed. That's its magnitude. and the angle is 35 degrees theta sub alpha, let's say. The wind is blowing from west to east going this way, and it is at 35 miles per hour. That is the magnitude again. But what about the angle? It is parallel to the x-axis or the I, and therefore it makes a 0-degree angle. So that's important to know that. So we're going this way. That is the true course. This makes some sort of an angle with the x-axis or the I vector, and this is v sub g, that means the velocity with respect to the ground. And so the ground speed has some magnitude, okay, miles per hour, and this is the angle that gives us north, that angle east, the true course. So the magnitude v, that means v sub g, is the speed, and the true course would be north. We find theta 90 minus theta. This is the one that we want, east. So that is explaining what we are going to do. This is the process that we are going to take. So having said that, let's add up the two vectors, this one and this one. To do so, we are going to use v as magnitude of v times cosine alpha I plus sine alpha j for each case, starting with this one. Now, 35 degrees is not a common arc. We have to put it into a calculator, and it will result, and we go with a couple of decimals, in the following. When we do that, 163.83 I plus 114.72 j. The wind is simply 35 times cosine of 0 is 1, sine of 0 is 0, so simply put is just 35i. Now we want to add these two, so these two will add up because they both have the I component, the other one remains. So when we add them up, we add these two numbers, we get 198.83 I, and this one we just write it as is. So having said that, we are almost there. What is the magnitude? The magnitude is square root of a squared plus b squared. So square this number plus square this number under the radical. That's what the magnitude is. And we're going to really go with a couple of decimals or one decimal, and then because it says nearest mile per hour, then with the closest, for the whole number. That's what it becomes, about 230 miles per hour. Okay. So again, nearest mile per hour. What about the tangent? B over A, 114.72 over 198.83, and you use a calculator. Theta is tan inverse of that. Theta is tan inverse of this number, 29.98 degrees. And okay, to nearest tenth of a degree. Okay, I hope you see that tenth of a degree is this. 9, next to it is 8, goes up to 10, that becomes 0, this becomes 0, and this becomes 3, 30 degrees. So now we have everything, and we say it is doing 230 miles per hour, going north 60 degrees east. So originally, as you can see, it's going north 55 degrees east. The wind, in essence, changes the speed. So 200 miles becomes larger because it's going almost in the same direction. So larger speed and a different true course. All right, having said that, let's go to the following topic, the dot product. The dot product has many applications, such as finding angles between vectors and calculating work, W equals F dot D, where force and displacement are vectors. It has the following algebraic definition. If V and W are vectors and we have scalars alpha. Here's the definition. V and W are A1I plus B1J in any format. W is A2I and B2J. Then V dot W is A1, A2 plus B1, B2 is just a scalar, okay? And the symbol V dot W is read V dot W. The dot product is also known as the scalar product or the inner product. The result is a real number and not a vector. So here's some properties. V dot W and W dot V are the same. V dot 0, 0 dot V must be 0. V dot V is the magnitude quantity squared of V. A times V dot W, it can be done in any format, the distributive property. V dot W is A1, A2 plus B1, B2. Also, it's equal to the magnitude of the V times magnitude of the W, cosine theta. Theta is the angle between the two. So, angles between vectors. So just right here, I want you to take a look at this one. If I want to find cosine theta, I'm going to divide the left side by the product of the magnitude. So this gives us this equation. Cosine theta is V dot W, which is A1, A2 plus B1, B2 over the magnitude of V times magnitude of W. And reminding you that magnitude of V is calculated as such, square root of A1 squared plus B1 squared. Very straightforward, everybody. So finding the dot product and the angle between the two. A is having components 4, -3, B having components 1, 2, both of them are vectors. And so here's the dot product, simply put, 4 times 1 plus -3 times 2. And we just get -2. And to graph them, let's just 4, -3, 4 units right, 3 units down would be the terminal point, like so. 1, 2, 1 right, 2 up. That would be the terminal point. And these are the two, and the angle in between. We can find it. So dot product and the angle, we can find it using this formula. We have to calculate, it's already done. The magnitude of V, square root of 4 squared plus -3, quantity -3 squared. And W is the same thing, square root of 1 squared plus 2 squared. I hope you see that what happens here. This is 25 and this is 5. That's why we get that. Now, I can multiply by square root of 5 over square root of 5. The bottom becomes 5 times 5, 25. So that's cosine theta. What is theta? Cosine inverse of this number. And you put it into a calculator and you get this one. Now, if you want to go with 1 decimal, then the next one is 0. So we stop at 3 and say 100.3 degrees roughly. So that's pretty straightforward. Finding the angle between two vectors, show that the pair of vectors is orthogonal, 2i plus 3j, comma 6i minus 4j. So just in short, orthogonal when it comes to vectors is the same as perpendicular when it comes to uh, lines. Okay, two lines are perpendicular, they make a 90-degree angle at the point of intersection. So having said that, orthogonal vectors. Two vectors are orthogonal when the angle between them is a right angle, meaning 90 degrees. The dot product of the two is zero because theta equals pi over 2. In other words, take a look at this one. The dot product is the magnitude of this times magnitude of that cosine of theta. Cosine of pi over 2 is zero. That's why. Okay. So let's multiply. Okay. Why when I said the dot product, 2 times 6 plus 3 times negative 4. Positive 12 minus 12, they add up to 0. And that's a proof. In other words, you calculate the dot product is 0, it shows the angle in between is 0. Show that the two vectors are parallel. V is 3i minus j and W is 6i minus 2j. Now, what about parallel? Parallel vectors. Two vectors V and W are parallel when the angle between them is either 0, theta is 0, the vectors point in the same direction, or 180 degrees, theta equals pi of 180 degrees, the vectors point in the opposite direction. In other words, V is alpha times W. So there are two ways to find it, what we are saying here. The easiest way, if we notice one of them is multiple of the other. For example, I hope you see that if I multiply this one by 2, I get 6i. If I multiply this one by 2, I get minus 2j. So method 1, notice W is 2V or V is half of W. So that's one way to notice that, and that's fairly easy. Okay. Method 2 is to calculate cosine theta using this formula. Okay. So V dot W, 3 times 6 plus negative 1 times negative 2. Then in the denominator, this one would be square root of 3 squared plus negative 1 squared. This one would be the square root of 6 squared plus negative 2 squared. So 3 times 6 and negative 1 times negative 2. So this is 18, this is positive 2. Then this one 3 squared and negative 1 squared. This is 9 and 1, 10. And this one 6 squared and negative 2 squared. This is 36 and 4, 40. 18 and 2, they add up to 20. Their product is square root of 400. I hope you know square root of 400 is 20. The answer is 1. So theta is cosine inverse of 1, which we know it to be 0. And that proves the two are parallel. Again, an easiest way would be what we just discussed in the first place. Either way is fine. Find the vector projection of V equals I plus 3j onto W equals I plus j. Decompose V into two vectors, V1 and V2, where V1 is parallel to W and V2 is orthogonal to W. What do we mean by that? I want to remind you what it really means. If you look at any vector, for example, this one in as a position vector, if you drop a perpendicular into the I vector or the x-axis, this is one component. If you drop a perpendicular to the y-axis, then that is the component along the j. So the v vector has two components, v1 along the x-axis, v2 along the y-axis. That's it. Here's another example. So v, drop a perpendicular along the x-axis and along the y-axis. So the two components are V1 and V2. So those are very obvious, but sometimes we don't use it in this manner as far as the X and Y axis are concerned. For example, if we look at the force here, okay, which is the weight, has two components, F1 and F2. F1 is parallel to the uh, ramp, okay. If you're moving it up, these two are working in opposite direction, and this one is perpendicular to the surface that can undo the friction force. So it cuts it. So you drop a perpendicular to the ramp, and then you can make a 90-degree angle. That's the concept, okay, everybody? So those are the two components we're talking about. So vector projection, the component of V along W may be found by projecting the endpoint of V onto the line L containing W. For this reason, magnitude of V cosine theta is sometimes called the projection of V on W and is denoted by projection of V onto W, a vector with magnitude of component V into W, which is a scalar. V1 is projection of V onto W, V dot W over magnitude of W squared times W. And V2 is simply the difference of the two. Just take a look. If you add V1 and V2, you get the V, the same thing here if you add F1 and F2. So you get one of them, you calculate them, the other one is the difference of the two, and component of V onto W is the projection of V over W, the magnitude. So for example, this one, I and 3J, we're going to go one to the right, three up, one to the right and three up. We are going to go with two uh, tick marks as one. Two tick marks as one gives us this one. Whereas this one, one to the right, one up, two tick marks gives us this. So now we want to find the vector projection of this one into this one. In other words, what we are looking at, if you extend this, think about this as the axis. Then what we want is this. Drop a perpendicular, and that is the component along the x-axis, now along this one, and this is the second component. I hope you see this vector is the sum of this one and this one. So when we say find the vector projection of this onto that, you can extend that, so that's a portion of that. In other words, something times that, okay? It can be larger, can be smaller. In this case, it's larger than the original vector I plus j. And this one is perpendicular to that, and that is easy to find. So having said that, we are going to go with this formula. And this is 1, 3, by the way. This is 1, 1. Okay, very straightforward. So V dot W over the magnitude of W squared times W, that is V1. So what is V dot W? 1 times 1 plus 3 times 1 W. That would be the magnitude of W, square root of 1 squared plus 1 squared, and the entire thing squared times W. Please understand, this is 2. It is raised to the power of 2. So square root of 2 becomes 2. And this is 4. So we get 2 times W, which is 2 times I plus j. Of course, I have even shown beforehand that it's larger than that. So let me erase my work so you can see that. It's very straightforward, everybody. I hope everybody is fine with that. All right, so having said that, V2 is the difference of the two. So I plus 3j minus, okay, 2i and 2j. Let's just do this. So we are going to write, okay, minus 2i minus 2j. These two add up to negative I, and these two, they add up to j. The final answer, therefore, is v sub 2 is negative I plus j. I can't emphasize this enough. I hope everybody is fine with that. So very straightforward. I hope we are fine with that. And here's how the graph looks like. Again, you can see this one is the same as that times 2. And this one is simply minus I plus j. We calculated it. Nice and easy. Find the work done in pushing an automobile along a level road from a point A to another point B, 40 feet from A, while exerting a constant force of 90 pounds. So we're going to go from point A to point B, a distance of 40 feet, and pushing it with a force of 90 pounds. So let's remind everybody something basic in physics. Work is the result of a force being applied to an object over some distance, which in turn may change the object's total energy. When the amount of force varies, we use calculus. Otherwise, work is force dot distance F dot D, and if it's in the same direction, just the product. So force is M times A. The weight is F equals mg. The work is F times D in the same direction. Otherwise, you have to figure out the angle. And if it's not in the same direction, it's magnitude of F times magnitude of D times cosine theta. So notice in this case, magnitude of the force is 90 pounds. The amount of distance, the magnitude of the distance is 40 feet. And because it's in the same direction, theta is 0. So it's basically their product. And the reason it's their product because cosine of 0 degrees, everybody. So 90 times 40, cosine of 0 degrees is 1. So it's 3,600 foot-pound. That's the unit that we use in old British system, also known as US customary. So remind you of the following. Joules is 1 joule is 1 Newton times meter, 1 kilogram meter squared over second squared. Joule, unit of work or energy in the international system of units, we say SI. It is equal to the work done by a force of 1 Newton when its point of application moves 1 meter in the direction of action of the force. James PreCalc Joule said that. They, in honor of his work, they called it joules. It equals 10 to the power of 7 ergs. And now remember, kilograms is 1,000 grams, meter is 100 centimeters, so gram centimeter squared over second squared, or approximately 0.7377 foot-pound. That's the relationship between the two. Bear in mind, the entire world uses the SI except the United States. But having said that, let's look at another example. A child pulls a wagon with a force of 50 newtons. The handle makes an angle of 30 degrees with the ground. Find the work done in moving the wagon 100 meters. So what is given? The force is 50 newton, the magnitude. The distance we cover is 100 meters. But in this case, theta is not 0 degrees. So it's not simply the product of the two. Because the angle is 30 degrees, we have to go with the magnitude of F times magnitude of D times cosine theta to come up with the work. So this is 50. This is 100. And this is cosine of 30 degrees that we should know it's a common arc, square root of 3 over 2. 5,000 divided by 2 is 2,500. So we get 2,500 square root of 3 joules precisely. I'd like to look at this extra example. Rewrite the Cartesian equation y equals 4x squared as a polar equation, just reminding you of what we know about that. Give me a second, everybody. All right, so I want to write this, and so I'm going to remind you of a couple of things. A polar r theta, rectangular x comma y, x is r cosine theta, y is r sine theta. So having said that, also x, y to polar, x squared plus y squared equals r squared, tan theta is y over x, and always adjust for the quadrant. So having said that, we know x and y, so we're going to write them. Y is r sine theta. Okay, so we're going to write y is r sine theta. For x squared, x is r cosine theta. We're going to replace. So y is r sine theta, 4 times x r cosine theta quantity squared. So this becomes 4 r squared cosine squared. We take them to the same side. Obviously, we can factor the r out. So either r is 0 or the parentheses sine theta minus 4r cosine squared theta equal to 0. So if you solve for r, that means you take sine theta to the other side, divide by negative, so minus sine theta. So let's just quickly show you. Minus sine theta, right? Divide by negative 4 cosine squared. You get r equals 0, r equals sine theta over 4 cosine squared theta. Very straightforward, everybody.